All right, so inside the Earth, there is a solid inner core that is made of iron and nickel, and there is a liquid outer core, and both of those together make the core of the Earth. That solid core is spinning, and the liquid is also spinning, and because it's made of magnetic materials, iron and nickel, that's what generates the magnetic field for our planet. Above the core is a layer that's a lot like taffy, but it's several thousand degrees of liquid rock. It's called the mantle. In the mantle, there are convection currents. The core is superheated. It causes the rocks in the mantle to rise when they get superheated. As they approach the crust, they cool off and they sink back down. So just like in a lava lamp, just like in the ocean, and just like in the atmosphere, as those materials warm up, they rise. As they cool off, they fall. Once you get past the mantle, you get to the crust, which is the top part of the Earth. That is actually where all the land is contained. It's the rocky, hard, crusty part on the outside of the Earth. That's where all the continents sit. The top part of the mantle and the crust are combined into a term called the lithosphere. So you can see here in the map, the lithosphere includes about the first 100 kilometers of the mantle and then the crust itself. And then underneath the lithosphere is the asthenosphere. Let me say that again, asthenosphere. And that's where convection currents are happening. So again, the mantle is heating up, it's rising, it's cooling off, it's falling. As you go deeper and deeper into the Earth, the temperature increases by about 1,000 degrees Celsius for every 2,000 kilometers you travel. The pressure is also increasing from about 24 gigapascals right underneath the crust to 360 gigapascals in the inner core. The reason that the inner core is solid is because of this immense pressure that's pushing down. Now, the first person who published a paper outlining the theory that the continents were moving was Alfred Wegener. Wegener theorized that the continents were moving in a process called continental drift. He came up with this theory because he noticed that some of the continents seemed to click together like puzzle pieces, so he began researching. And he discovered that there were mountain ranges in different countries that seemed to match up with areas that were clicked together. He also found fossils of land-based creatures that could not swim, that were on different continents and were separated by thousands of miles of ocean. So he theorized that all the continents at one point in the past were all clicked together into a giant landmass that he called Pangaea. Originally, his theory was rejected because he couldn't explain how the continents were moving. And that didn't come about until the 1960s. There was a research vessel called the Glomar Explorer that was taking samples of the ocean floor in the Atlantic. And they were in the middle of the Atlantic at a mountain range called the Mid-Ocean Ridge. When they would reach down and they'd take samples, they found that the rocks in those areas were carbon dating to about 1,000, 2,000 years. The further away from the mountain ridge they went, the older the rocks got. And so then they came up with the theory that in the middle of the mountain range was a divergent boundary, a boundary that is two plates pushing apart. And every time the plates would push apart, a little magma would come up, and that would solidify into new rock. And the process would begin again. And so it was like a conveyor belt pushing the continents away from the rift. At the other end of the rift is a convergent boundary. A convergent boundary is where two plates are pushing together. In this case, the North American plate is bumping into the Pacific plate. The continental crust, which is made of granite, is less dense than the oceanic crust, which is made of basalt. And so the ocean crust is being pushed under. And as it gets pushed under further and further, it gets pushed into the mantle, it gets melted. Once it gets melted, it releases vapors and gases that build up pressure underneath the crust. The points where that pressure is building up is a volcano, because a volcano is just a big vent in the crust. Every once in a while, the pressure builds up so much that the volcano erupts, and you have a volcanic explosion. So this is Seattle right here. The oceanic plate that Seattle is on, the continental plate that Seattle is on, is subducting the oceanic plate, and this mountain, Mount Rainier, is the vent that explodes occasionally to release the pressure. When you have two pieces of continental crust that bump into each other, neither one is going to go under, so they wind up denting each other just like a car crash. Unlike a car crash, though, you don't get dents in the hood, you wind up with mountain ranges. And the best example that we have right now is the Himalayan mountains, where Mount Everest is. This mountain range is actually currently growing because the Indian plate is still smashing into the Asian plate very slowly, and so the mountain range grows a little bit each year. A divergent boundary is where two plates are moving away from each other, so just like the mid-ocean ridge that the Glomar explorer discovered. This can also happen on the land, and when that happens on the land, you wind up with a rift valley like this one in Africa, where the two pieces of land are moving apart and you're creating a valley, a rift in the middle. A transform boundary or a transverse boundary is one in which the plates are sliding parallel to each other. One's going north, one's going south. Earthquakes are very common in these regions, and you also sometimes get tsunamis as a result of earthquake activity. The best example that we have in the United States of a transform boundary is the San Andreas Fault in California. All right, so this is the scale that's used to measure the speed of winds in a hurricane. It's called the Saffir-Simpson scale. The higher the category, the more dangerous the hurricane. You probably already know this, especially since we went through Hurricane Matthew back in September. That caused us to have some weird days, including this coming Friday, which was supposed to be a day off, but we have school this Friday, as you probably have already heard through the multiple Connect Ed phone calls that have gone home, because this is a makeup day for that hurricane day. All right, so hurricane season in the Caribbean starts on June 1st and it runs through November 30th. However, it's entirely possible to have a hurricane at any time of the year. In fact, I read a news article the other day that said that there's a hurricane out in the Atlantic that is not a threat to land at all, but it's there and it's April. It's important to know the evacuation route for your area in case you have to evacuate before a hurricane. You really don't want to try to evacuate during a hurricane, so knowing how to get out before it happens or before you need it is the best way to go. It's also important to keep supplies for your family: food, water, medicine. If you have little babies in the house, you want diapers. You want to make sure you have gas in your cars, just because after the hurricane goes by, there may not be power for several days or even weeks, and you may not be able to get to a store to purchase the food that you need or the gas that you need. Because if there's no power, then the store doesn't have a cash register that works. If there's no power at the gas station, then the pumps don't pump the gas out of the ground. It can't get into your car. So it's important to have those as a backup. Also, if you live along the coast or if you have a lot of windows in your house, you might want to consider boarding up, especially if the hurricane goes above a Category 3 and there's going to be a lot of wind. The Fujita scale is used to measure the speed of tornadoes. A Category 5 hurricane, which has wind speeds over 156 miles an hour, would be considered an F3 to an F4 tornado. Now, here in Central Florida, we typically get F0 to F3 tornadoes. They're damaging, but they're nowhere near as damaging as the gigantic mile across F4 and F5 tornadoes that are common in the Midwest. And if you haven't seen the movie Twister, you should go check it out, because that's a really cool movie, not a documentary, movie about tornadoes. In the spring, we typically experience drought conditions like we are right now. And the reason that it's drought, the reason it's very dry, is because for the month of April 2017 right now, we have not received any rain in this area of Florida. And all the bushes, all the trees in the forest, they get drier each and every day. And as a result of that, there's an increased risk of forest fires, just like the fire that we had next to our campus a couple of weeks ago. As bad as all of that may sound, at least we don't have to worry about earthquakes and tsunamis and volcanoes here in Florida. Those are some natural disasters that we do not have to worry about.